All right, so we're going to discuss polynomial end behavior. And so, in our introduction to polynomials, I spent a lot of time talking about how, the most important and powerful term in the polynomial is that highest degree term. Okay, and so everything that's involved with that, the leading coefficient, the sign of the leading coefficient, what the degree of the function is, all of that is important to determining a polynomial's end behavior. And so obviously we care about what happens in the middle, and we'll talk about that in another video as well. But another important piece of that is just focusing on what happens at the ends, right? And we sort of talked about that a little bit with quadratics when we talked about, is my quadratic, is my parabola opening up, or is it opening down? Right? Because that affected the range of values that we could get out. Right? If it was opening up, then I had some minimum value, and I could get all sorts of y values above that. And the opposite was true if it was opening down, where I had a maximum of my vertex, and I would only get values below that. Right? And so if you think about, as we progressed from talking about linear functions to quadratics, sort of the things we could do with quadratics were more intricate, and there were more things to talk about and more interesting things to think about. And the graph itself got more complex. As we continue to move up in degree, the same thing continues to happen, right? We're going to look at, okay, what does opening up and opening down mean? Does it always do they always end up facing the same direction? Do they always open up? Do they always open down? What causes it to open up or open down? These are the sorts of things that we want to talk about when we discuss end behavior. Okay, so I mentioned that there are sort of two things that within that lead coefficient. There's the lead coefficient within that lead term, the highest degree term. We care about the degree, we care about the coefficient, and those two things are both going to affect different things. So the first thing we'll talk about is the degree of the function. Right. So the thing we care about when we're talking about the degree of the function, yes, we care about the number of it, right? Like how big it is. And if it's bigger, we're going to have more complexity. But when we're talking about end behavior, the thing we care about is it odd or even? Right? Is it odd or even? So we have a quadratic, that's a second degree, that would be an even degree, right? If I have a cubic or even a line, a linear, that's x to the first, x to the third, those are both odd. And so that affects our graph. Now, if we have an odd degree, so I guess I should do a line here. If it's odd, then it ends facing opposite ends in opposite directions. Right, so the easiest one to think about is a line. Right, if I have a line, we agree that if I put that on the coordinate plane, right, it ends in opposite directions. They're not, both arrows are not facing the same direction. One is going up, one is going down, right? Maybe I could think about a cubic function, which you guys don't necessarily know what that looks like yet, but a cubic function looks something like that. So x cubed, right? I've got going up and going down, opposite directions. The opposite is true for evens. So they even graphs are going to end in the same direction. It's probably not the best way to be saying that, but same direction. So if you think about a quadratic, right? Our quadratics were always either both opening up or both opening down. There was no opposite. I didn't have one side going up and one side going down. They were always ending in the same direction. And that's because it's an even degree polynomial. Okay, so I would have something like that. So, and the same is true for something of higher, maybe the next one would be x squared, right? And x squared, they're both going to be, or not x squared, x to the fourth. We can have something like that, sort of like a w, but they both end up facing up. They're both going the same direction, right? So that's what we care about. Are they going up or are they going down? And so in the case of odd degree polynomials, they end in opposite directions. So one side going up and one side going down. In the case of evens, we have one side. We've got both sides going up or both sides going down. So it either completely opens up or completely opens down. Okay. Now, the other thing that we talked about with quadratics is if I have a negative a value, then that would flip my parabola or reflect my parabola over the x-axis. So then it was opening down, right? So the second question we have to ask ourselves is the sign of the lead coefficient. So we don't really care about the value much. We just care about the sign. Okay, so if it's positive, that's sort of the default position, right? So if it's positive, then it's not reflected, right? Nothing changes. So if it's positive, then we've got opening up, or we have a positive sloping line, right? It goes from negative to positive, something like that. That's the default position. Maybe in an x cubed, we've got something like that. But the default position is, for even, the default position is opening up, right? So we saw it in this case here, opening up. Or if it is a odd degree, then we have going up on the right and down on the left. So up in the positive direction, down in the negative direction. Up, down, up, down. Okay. On the other hand, if my lead coefficient is negative, then what happens is it just flips, right? So if it's even, then it's going to open facing down. Or if it's odd, oopsies, we know what happens like if I change a line to a negative slope, right? Instead, we go from high on the negative side to low on the positive side. So just like that. So it just flips it, right? It's reflected. So this side, this right side over here was above, and then it's been reflected down. And this left side here, maybe I should have done that in another color. And this side was below, and it got reflected up by the negative. So then we end up here and here, right? So same story with something like a cube. It would just be the opposite direction. And that's not very pretty, but it is what it is. Okay, so there's a nice little chart you can make yourself if you don't want to, if your memory's not great, if you want to have something to reference. And so it's sort of like I don't know if you guys have taken biology, but sort of like a Punnett square. And so on the top, I'm going to do degree, we'll do even and odd, right? And then on the left here, we'll do coefficient sign. Oh, oof, that was rough. I can't spell. And we'll have positive and negative. Right, so if we have an even positive graph, then it opens facing up, right? So same direction. Opening up. On the other hand, if we keep it an even degree, but we change the sign to negative, then still same direction. But instead of opening up, we're going to open down, opening down. Right? All right, well, if I have an odd, then they're going to be opposite directions. And it's going to be positive on the right, or opening up, not opening up, there's not really opening up, but positive on the right, negative on the left. Oh, that's maybe the wrong color. Right. So positive on the positive side, right, and then negative on the negative side, negative on the left. Negative side. Finally, if it's odd and negative, then that flips. Still opposite direction. But instead, it's going to be positive on the left, which is the negative side, and negative on the right. Positive on the negative side, and negative on the positive side. Right, so if we wanted to, we could do a little, a couple little sketches, something like that. Okay. All right. So we'll look at one example here, just for the fun of it. X equal to 2x to the fifth minus x squared plus 2x plus 1. Right, so all I care about is the highest degree term if I'm looking at end behavior. That's that term right there. It's a odd degree. So we're looking over here at this column, it's odd, which means it's going to end in opposite directions, and then it's a positive 2, so it's going to be opposite directions going up on the right and down on the left. So if you wanted to, you could give a little sketch. Maybe it looks something like that. And then we could say opposite direction. Up, right. Down on the left. Right. And you'll notice that I sort of just disregarded this portion right here when I'm talking about end behavior, right? So in the next video, we'll talk about graphing and sort of starting to care about the whole parabola in its entirety. But for now, we're just going to look at end behavior.